Um, Hello, everyone. Good morning. This is Mark Gian Abel Domaro, and I am presenting projects 3, 4, and 5 for Abstract Algebra. I am from BSCD Math 3B, so let's start. So, project 3 is we will check if our group table, here is our group table, and we will see if it is a cyclic group. So, for a cyclic group is one, it must be an abelian group, and two is it must have an element that generates all the elements. So, as we can see in here, for example, R star F is U, but F star R is A here. From that, we can see that it is not abelian. So, from that already, we can say that this is not a cyclic group. But let's see if there is an element that generates all to be sure that this is not a cyclic subgroup. So if we look carefully, R generates R because R star R is R, and R only generates R. So next group is F. So F star F generates E, then F, then for F cube, it's F star F. Or in this case, since we know that F star F is E, we can just continue with E star F is B. And then B star F is R, and R star F is F. Continuing this, we have F star F is E. So as you can see, it will repeat again. So F generates E, B, R, and F. Next is R E. No, next is E. E star E is R star E is E. So we can say that the element E generates E and R only. For B, we have B star B equals E star B is F star B is R star B is B. So we can say that the element B generates E, F, R, and B. Next, R star R generates big letter R star small letter R generates small letter R. Next is U star U generates R star U generates U. So U generates U and R. A star A is R star A is A. We can say that element A generates R and A. Y star Y is R star Y is Y. The element Y generates R and Y. Here's the list of all the elements and what they generate. So, for example, element B generates E, F, R, and B. So, since the group is not cyclic, we can say that the improper subgroup, which contains all the elements of the group, is also not cyclic. So let's continue on from smaller to bigger now. Subgroups. So the trivial subgroup containing R, we can say that R star R is R. And since there is only one element, element R is generates all the elements of this table. So we can say that the trivial subgroup is a gen is a cyclic subgroup. So next is R star E or the subgroup of R and E. So we can see here that this is an abelian group, and E star R no E star E generates R and R star E generates E. We can see that the element E generates all the elements of the subgroup. So this is a cyclic subgroup because it fits the two conditions. Number one is it must be an abelian group, and number two is it must have an element that generates all the elements of the group. For R star R, this is also the same case. We can see if there is a symmetrical diagonal from this diagonal, this is symmetrical, and aside from that is that R generates all elements of the set. Same with R star view, U generates U and R, and then this has a diagonal or a slanting line of symmetry from upper left to lower right. So R star A, the same case, looking from the upper left to the lower right, there is a symmetry. Aside from that, the element A generates R and A. Next is R and Y, same case, upper left, lower right, there is a line of symmetry right there. And Y generates R and Y, which is both the elements of the set. So next is moving on to the four elements. We have here R, F, E, B, and F. As we can see here, F generates E, so let's look. F star F is E, E star F is B, B star F is R star F is F, so it generates all the elements of the set, and there is a line of symmetry from the upper right to the lower left. So since this is commutative, or this is an abelian group, and it has a generator, we can say that this group is a cyclic subgroup. Next is this one. So you can see upper left to lower right, there is a symmetry. And aside from that, there is E star. There is no, there are no generators. And since there are no generators, we can say that this is not a cyclic subgroup. Wait a second, I'll just plug this laptop. Next is RERY, upper left to lower right, there is symmetry. So once again, this is an abelian group. And next is there is no generator, so this is not a cyclic group. So the list of all the cyclic groups are the set or the subgroup RFEB, the subgroup RYRA, RU, RRE, and the subgroup R. Those are the only cyclic subgroups. Now, for the number four, for the project four is we must relate the order of the subgroup to the order of the group. So this is the order of the group. So we will count the elements. So 1, 2, 3, 3, 4, 5, 6, 7, 8. So for the impropers, for the group, there is 8 elements. And so let's continue this for the equals. For the order of the subgroups, I will write here the right hand side of the equal sign. So there is an 8 for the improper subgroup. For the improper subgroup, there is one element. Next is there is the set of subgroups of two elements, the RE, RU, RA, RR, and RY. And lastly is the four elements which are RFEB, REUA, and RERY. There are no further elements. So there is the 8, 1, 8, 1, 2, and 4. And if we observe closely, the factors or the factors of 8 are 1, 2, 4, and 8. There is 1, 2, 4, and 8. So we can see or we can say that the relation of the order of the subgroup and order of the group is that the order of the subgroup divides the order of the group. So lastly, for the project number 5, so this is the R. So this is R. This is the permutation group. This is F. This is E. This is B, R, U, and A, and Y. So in order to showcase that, as I have here, wait, where's the paper? Here. Here is what I use. So this is how to do it. So one is I use a square, right? So you have a square here. Then I'm gonna write so 1, 2, 3, 4. Yeah, so here you can look 1, 2, 3, and 4. Here pala. Yeah, 1, 2, 3, 4. Then you look one, right? So at the back, so to make sure that you're not lost, that one. Then for two, you pinch the back side, and then where your finger is where you write 2, 3, and 4. So in here, so let's continue on. Yeah. So here, and then F is the counterclockwise. So from here to there, so you can see in position 1 is 4. So 1 is 4. In position 2, so in position 2 here goes 1. In position 3 is 2. And in position 4 is 3. So this is 4, 1, 2, 3. For E is 1, 2. In position 1 is 3. In position 2 is 4. In position 3 is 1. And in position 4 is 2. So that's how we did it. And then for position B, this is 1, 2, 3. You can see 1 is 2. In position 1, previously position 1 is 2. Number 3 is in position 2. Number 4 is in position 3. Number 1 is in position 4. Next in R is the right. So like this. So we can see that in position 1 is 2. In position 2 is 1. In position 3 is 4. Here 4. In position 4 is 3. For you, it's the flipping horizontally. So from this, so the original one for 3, 2, we have flip. And then 3 is in position 1, 2 is in position 2, 1 is in position 3, 4 is position 4. Next is for the A, we have the left turn. So yeah, here. So this is horizontal naman. So 1 is here. Then you can see position 4 2 is in 4, 3, and then 2 is there. Next is the right, or no, the left na. So here, and then we can see that 4 is in position 1, 2 is in position 3, and like that. So now is we operate it. So F star R, and here is it's like the composite function. So we start or we look at the right side first. So 1, so 1 in here, So in here, 1 is 1. And then we look at 1 in this side, there is 4. Then 2, 2, 2, 1. No, yeah, so 2 is 1. Then 3, 3, 3, 2. So that means 3 has 2. Then 4, 4, 4, 3. So that means the answer for is 3. So we used it on each of the elements. So F star R, F star E, F star E, F star B, F star R, F star U, F star A, F star Y. So I'll give you 5 seconds each. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 4, 5. So as you can see, like each we used or we operated it both sides on each of the elements so that you can see that there. And then if we make a table of results from all the answers, if we will have this. And this is the same as our own element or our group table. So we can say that since our group table is a group, then the permutation group or the permutation table is also a group, meaning that when we use the permutation, we form a permutation group. So this is all. I, Marky, and Abel Lumarot, thank you. This is all for the video. Stop sharing and stop recording.